Okay, there were definitely some things we didn't cover today, even though we did a lot of stuff together. I want to go ahead and record these so that you get a little more practice with ionic equations. And then there's one topic I really just didn't get to talk about, which was when we form gases with reactions. So the first are two practice problems. I recommend you pause this video and try to work these yourselves. So take these chemical names and use the observation of the experiment to determine what chemical reaction occurred and write that net ionic equation for both of these. So I'll encourage you to pause the video, try to work these on your own, and then come back to this video. Okay, so this is a classical example of a problem where we're given the names. This is why we got to be kind of second nature with nomenclature. Silver acetate and sodium chloride are combined and a white precipitate forms. So some precipitate forms, we've got to figure out what it is using those solubility rules. This is a double replacement, so silver is going to hang out with chloride and sodium is going to hang out with acetate. Now, one of these is a precipitate. There's one rule I asked you to memorize, well, two rules I asked you to memorize. All alkali metal salts are soluble, so I think this is going to be a soluble compound, but I want to check my solubility rules and make sure this one is insoluble. So when I look at my solubility rules, all compounds with chloride are soluble except, and silver is an exception. So that silver chloride will be a precipitate. It will be a solid. So right now I have my balanced molecular equation, which I'll abbreviate as BME. You could go through the complete ionic equation, and I'll just do that so that you have some practice with it. Here's my solid. I encourage you to get in the practice of underlining your solid. That will remain intact both in your complete ionic and in your net ionic equation. That solid does not dissociate. We leave it as an intact species. But anything I did not underline fully dissociates in solution. So when I write the complete ionic, I would write all of these ions with their states of matter and their charges . Whether they are a reactant or a product. Got all the species with their charges. Now again, my net ionic is not going to contain those spectators. So anything that's the same on both sides of the equation, I would not put into my net ionic equation. These are called spectator ions. They're just watching the action. They don't really participate. But anything that we didn't cross out will be put in that net ionic equation. So here's my NIE for that first process. All right, pause the video, see if you can take any of those lessons learned from that one and apply it to the second reaction. Okay, lithium dichromate plus lead 2 nitrate are combined and a yellow precipitate forms. Okay, so we know there's a precipitation reaction. Well, lithium is going to hang out with nitrate and lead is going to hang out with dichromate. I know that all nitrate salts are soluble and all alkali metal salts are soluble, so lithium nitrate is definitely a soluble compound. So I don't actually even need to look at the solubility rules. I know that lead dichromate should be insoluble because this one is soluble and the problem is telling me a precipitate forms. Now this isn't balanced. I have 2 lithiums here and only 1 here, so I'm going to stick a 2. 2 nitrates, 1 lead, 1 chromate, 1 dichromate. Great. I have a balanced reaction. I'm going to underline that solid. My NIE is going to that solid. And the shortcut I was trying to tell you is to just balance the NIE by putting in the ions that you need to create that compound. So the lead ion and the dichromate ion. So now we have a balanced chemical equation. This would be my NIE. Missing is the complete IE. You're not seeing the lithium and the nitrate ions, which are spectator ions. But if I were to do a complete ionic equation for this, I could draw all of the not underlined things as fully dissociated. So 2 lithiums, 1 dichromate, 1 lead, 2 plus, and 2 nitrates, yielding 2 lithiums plus 2 nitrates plus lead 2 dichromate. Not dissociated because it is a solid. Now again, if you have a subscript of a soluble thing and it's a monatomic ion, that subscript becomes a coefficient. If it's a polyatomic ion, those subscripts say subscripts. They don't break up. Polyatomic ions stay intact. If you have a coefficient, then you distribute that coefficient across both species. So this will give me 2 lithiums and 2 nitrates. Here I see that lithium and nitrate are my spectators, so those would go away when I write my NIE. Hopefully that gave you a little more practice writing NIEs. There was one other part of the worksheet I didn't fill out when I was live with you, and that was the separation scheme, though we did go over it in class. There were 2 options for your separation scheme. You could have added sodium chloride first, and you would have gotten silver chloride, and you would still have barium and iron in solution. The NIE for that step would be Ag plus Cl minus yields AgCl, everything with states of matter. And then if that was your first one, your second one would have been sodium sulfate. So I would get barium to precipitate, and I would still have iron in solution. So barium plus sulfate yields barium sulfate. And then I could add sodium hydroxide, and I would get iron hydroxide to precipitate. So that would be iron plus 3 hydroxides yields iron 3 hydroxide. You also could have done the same scheme where you swapped the order. So sodium sulfate here making barium sulfate, and then sodium chloride here making silver chloride. Both of those were possible options. I'm going to stop this video, and I'm going to put the acid and base stuff in another video. So go to that other video when you want to have a chance to look at those strong and weak acids.